Okay, CNC Club is having a little look at an acquisition that we've just got. It's a Roland engraving machine. It's a PNC 2300, which is quite an early CNC machine, and we managed to get this at a good price because it was definitely not a happy machine. So we're going to have a look at some of the things that have been changed to get it working, and yeah, let's have a look. So if I can take off one of these panels, we'll have a look at one of the main issues with the machine before it was restored. Oops, there we go. Now then, the machine relies on drive cables to transfer from a stepper motor the motion from a rotary motion to a linear motion. A bit of an odd arrangement. We'd normally do this with a tooth belt now, but this used nylon coated steel wire to do the necessary. Now, the wire that was in there, the original Roland one, which is what had caused some of the issues, has obviously gotten somewhat worn and was producing some rather poor results from the engraving. And the thing with an engraving machine is you just need it to engrave, not do some wiggly wobbly random characters and things. So this was one of the issues. So I've Colin has replaced the drive cables in this machine, and I'll be able to put a link into where I got them from. So this is purely nylon coated 7x7 stainless steel wire, and if I remember, it's probably 1.6 mil diameter on the outside, 1.4 for the stainless steel wire, and the ends were made off using these little stainless steel wire ends, and I'll put a link in for those as well. We did actually move this post from here to here, which is the only modification that was done to this drive chain, and that was just to allow for this extra length here, because the original Roland drive cable used that, so there was enough room with that back here without losing any travel on the y-axis. So that's basically got this machine drivetrain wise fully functional again. Okay, now one of the other things that had to be changed was the Roland main board for the interface and drive electronics, and the reason for that is that Roland used their own CAM2 system that used their software to talk to this machine. Now, this is quite an early implementation of a computer-aided manufacturing interface. We tend to use G-code now, which this will not interpret. So unfortunately, not having any Roland software to talk to this machine, this board works absolutely fine. If I had the original Roland engraving software, I could have left this board in there with a power supply and it would all work absolutely fine. But unfortunately, I have nothing to drive from a computer this machine with. So we've removed this and we've implemented a different system, and we'll have a look at that now. So if we take the cover off, we can see that there's not much left of the original Roland equipment in here. We've implemented a new 24 volt power supply. The reason for that was that on the Roland power supply, the rectification and smoothing were done on this main board. So they were left as they were. And it was easier to just simply get a Chinese 24 volt power supply, mainly used for LED lighting, which is a very good price because they're making a lot of them now, and just literally drop this in instead of the transformer and then making up some rectification and smoothing. It's all done in here. This then feeds the stepper drivers, which have been hooked up to the steppers using the original wiring. So that's part of the original system, is the wiring which has been reutilized. The stepper drivers are fed from a Mach 3 interface board, which again is a good price from China. So this looks after the stepper drivers. The limit switches come in here, which I'm using as home switches, and the Spindle relay is switching on the Spindle from software. So this basically has upgraded this to a G-code driven machine using the parallel port rather than Roland's proprietary communication protocol, which I can't talk to from the system that I've got at the moment. One of the things that we have kept, and Colin installed this, is the original fan, which is 24 volts, which is handy because it's a 24 volt power supply. Also, the spindle motor is 24 volts as well, so that can be fed from this power supply through the relay out to the actual cutter head. So that's what's been done in here. Basically, it's all been taken out and then replaced with new drivers, a new interface board, and a new power supply. Colin had taken a bit of time to tidy up all of the wiring, which is what we see at the moment. So that's basically the interface, power supply and driver section completely replaced in the engraver. So we'll have a look at some of the other bits that we've changed in the spindle speed side. Okay, some things have been changed up here. The original emergency stop is all as original, which is great. You hit that button and it kills the power to the machine. Everything stops. Very reassuring, great feature, and that's definitely been kept as original. The spindle speed control on the original was a bit non-proprietary. If it was just a simple 24 volts in and then the speed control out, I would have kept it. I've swapped it out for a Chinese 24 volt speed controller. I think it's a PWM, pulse width modulation controller, which works really well, and it's got the simple that's basically 0 RPM, and that is maximum RPM. So the good thing with this is it came with a switch, which I was a bit concerned about to start with, because the I wasn't sure if the thing would actually start up at the rate that was set, and then you could switch it off, or whether it would wait for the switch to start. Well, it turns out that this thing fires up at this speed, and if you press the switch, it stops it, and if you press the switch again, it starts again. Well, that meant I could throw the switch away, and when the relay, which this is now hooked up to on the Mach 3 controller, asks for spindle, it sends 24 volts to this board, and it runs the spindle motor at whatever rate has been set on this potentiometer, and then when it's finished its run through the G-code, it switches off the spindle. So it's spindle on at this speed, spindle off, and that can be controlled from software anyway. The keypad that controlled the motion on the Roland machine has been removed. That's effectively redundant because all of these functions can be achieved from software now, so they're basically looked after on the computer. There's no need for these controls here. They're done on the screen, so we'll have a look at those a little later on. So now we're going to take this cover off and see what's going on inside. Let's just lift that out. Here we go. Now again, we have the stepper motor here for the x-axis, which had the cables changed out, just the same as the ones on the y-axis, and we can see moving the y-axis that has the new cables, the upgraded cables in there. This was moved back just the same as the other side, just to allow for that little bit of extra travel there. The original ribbon cables were reused because that brings out the stepper motor and the limit switch and the spindle motor connections. The limit switches were broken out with a little little interface board that I've put in there, a bit of Vera board, which was quite handy. So these basically feed back, as we saw earlier, onto the Mach 3 board for the limit switches, and the speed control board is this one here. So that literally was popped in here with a display to control the spindle speed, which is again switched on and off by the relay on the Mach 3 control board. So that's pretty much that. This is the stepper motor that controls the motion for the y-axis. Again, the original wiring was reutilized, and that's about it really. So the keypad was taken out, the speed control was taken out, the emergency stop stayed in, and all of the ribbon connectors and the original wiring was reutilized as much as possible. So that pretty much concludes what was done to the machine. Okay, one of the things that's worth noting on this Mach 3 control board, which is a little unusual, is that the limit switches that come in on here, there's a common back here, that's a ground, and then there's like Z, Y and X for limits. So these limit switches rely on the 12 to 24 volts, in other words the 24 volts from this power supply being connected in to these 2 points here and here, and the one on the right, let me think, which is nearest to the thing, that's well, you have to work out which is which, but these two connections here are from this power supply. Now this power supply is used to work these opto isolators here, which connect back to the parallel interface. Without a power supply connected here, these will not work. They are using the machine's power supply, which effectively is machine side, to connect back to the computer. So that's just something worth noting, because without that, these do not work. So 12 volts to 24 volts in here, all these are completely redundant. It can take a little while to realize that that's necessary. It's geared up for those voltages, not 5 volts. So if you're having issues with that, get yourself 12 to 24 volts connected up here. The other one is the spindle connection from the relay, which I've hooked up to the speed controller. So there's just something to watch out for using this Mach 3 board. And obviously you need the USB 5 volt power to power the board and the 25 pin D connector for the parallel interface. This actually had a Centronics interface to start with, which I hadn't got the connector for because this is a different one. So there we are. That might save people a little bit of time with that interface board. Okay, let's have a look at the configuration that I've got set up for this machine. This is only for this machine. Yours is going to be different, but I'm sure that people would like to know where I've got everything set. So we need to go up to the applications menu and then down to CNC. I've installed this all previously, and then we're going to go to the Linux CNC step conf wizard, which is going to allow us to make some modifications to the steps and pins, etc. So I've already set this up, so I'm going to modify a configuration I've already got. Okay, so we'll move on. Engraver 1 step conf. I'll open that file. Now the first thing we're going to look at is the axis configuration XYZ. I've got everything set to millimeters. All of this I've left straight out of the box. I haven't changed any of this. We've got one parallel port and I've left all of this as stock. So let's move forward. This is a setup for the parallel port. I've got pin 2 as X step, pin 3 as X direction, pin 4 Y step, pin 5 Y direction, pin 6 Z step, pin 7 Z direction. The rest are unused apart from pin 17, which will be spindle on, because I've got that relay connected up to the spindle power supply. Inputs from the machine back to the PC, I've got pin 12 as home Y, pin 13 as home X, and pin 15 as home Z. I had to swap these two over to get it to work. Not too sure why, but that's just something to note. It would normally be X, Y and Z, but that's how this is set up. The parallel port base address is 378. That's actually been pinned down in BIOS to B378, not set to auto, so that when this machine is fired up, that parallel port is at that address and that address only. I've left it on Shoreline for the output pin out presets. Don't hit that after you've adjusted all of this, because it'll change them all to whatever it wants and not what you want. So that's my configuration, possibly not your configuration. Moving forward, I've put the include custom graphical user interface panel on, because I want access to the HAL so I can monitor the input pins. The rest of it include classic ladder PLC, programmable logic control, ladder programming protocol. I don't need that, so I've left that off. So let's move forward now. Axis X, 400 steps per revolution. 4 for the micro stepping. I've set that on the stepper drivers to 4, so that corresponds to that. This has worked out at 1.1 to 1 for my pulley teeth. I had to do a little bit of division on the actual size to the step sizes. Lead screw pitch 5mm, that was pretty much the same. Maximum velocity 50 millimeters a second, maximum acceleration 100 millimeters a second. The table is set to 300 mil for the X axes. The home switch at 300 and the home location at 10. I've kept the velocity down on this to 10, which is quite slow, because I was getting a contact bounce when it got to the home position, which meant it thought that the switch was closed when it came back for the second check. So if you're having issues with not finding your home switch locations, drop down your velocity. For the y-axis is exactly the same, except that the the table size obviously is different. This is set to 230, everything else is set exactly the same. On the Z-axis this is a bit different. I had to calculate out the ratio, which is down at 0.792 to 1 because it's on a lead screw, not on that drive belt system. Maximum velocity 10, maximum acceleration 20. The home location again is 10, but the table travel minus 15 to 20. Home location switch is 20, that's right up at the top. Home search velocity 4, which is pretty slow, and that's pretty much it. That's all of that setup, and that's done. So I'm going to save that configuration, and then we're going to actually make the machine work. Okay, well, we're actually going to do some machining now. So the first thing to do is to launch the configuration that you've set up. Here we go, and I'm going to home the axes. First thing to do is to hit the emergency stop and then fire up the machine on the control, and then we're going to do home all for home all the axes. So first thing we'll do is the Z axis. We'll come up to the limit switch, and I've told it that 10mm down is its home position. It'll now wander off and hunt for the home switch on the X axis. So it now knows where the end is, and it can come back Y home, and we're ready. So that's all homed. The spindle is under the control of software, so I can actually start the spindle. And I've got it set to 80%. And I can stop the spindle from here as well. But software will be able to control that also. So let's put the cutter into its cut position by locating it down anti-clockwise. I think my hand's in the way of your view there, mate, sorry about that. That is now actually ready to do some machining. So all we have to do is hit the start. So it's fired up the spindle. And we're actually engraving. Now this is a bit of MDF, not my first choice of material, but hopefully it will demonstrate that the machine is doing what we need it to do. Okay, so the G-code's all run, the spindle shut off, and we can happily manually control the machine, bring up the Z-axis, drop that up to about 10, and using shift and this key, we'll put that back out of the way and have a look at what we've got. So there it is, and I'm just going to brush off some of that dust there. We'll put a little bit of paint on that in a moment. I might get the vacuum out in a moment, and there we are. There's our engraved final product. Okay, just to finish off the engrave, I'm going to pop some little bit of acrylic black paint on there, and then scrape it over the surface to fill in the gaps. When it's dry, we get a lovely sharp impression. And that concludes our little tour of the Roland PNC 2300 engraving machine, rebranded. And watch the stuff slide around under a cutter. Perfect. There it goes. Should probably, I think I'm going to stop that there actually.
Asshats.
Yes. Well, we planned just about everything out apart from the things sliding around.
Never work with children and animals in reluctant CNC machines.
Yeah, but what we've done is we've put two neat holes into a perfectly good workpiece, which has trashed it now. So yeah, if you
spin it,
if you want to if you want to learn how to do that, then just follow these instructions.
Also, how to land drones in trees.
Yeah, I think we'll put that in the bloopers section.
Yeah, it's got to be
and we'll start again.
Yeah.
Okay, so we'll stop for a moment.
Well, you only need to do that, but you haven't got to do all that again, have you? Because you got that. Do a bit of a blip cut there.
Yeah, I think we stop recording now.
Yeah, I have.